we continue with the second test. Its name is How Building Design Changed After 9 September. When buildings fall, people die. It's a terrible tragedy. It's also a big engineering problem. In 1995, a building in Oklahoma City collapsed after a bomb exploded. In 2001, the World Trade Center towers collapsed after a terrorist attack. These events made engineers ask, how can we stop this from happening again? In Oklahoma City, a bomb exploded near a building. The building had 9 floors and was made of concrete. Only a few columns were broken, but that caused other parts of the building to fall too. This is called progressive collapse. It means when one part breaks, the rest of the building also falls down. In the Oklahoma City attack, 268 people died. A month later, the rest of the building was taken down on purpose. On September 11, 2001, 2 planes hit the World Trade Center towers. The heat from the fire made the steel columns weak. Other parts had to carry more weight and could not hold the weight. So the tower fell. Before these events, engineers did not think much about progressive collapse. Now, they know it's very dangerous. Today, engineers try to design stronger buildings and use better materials. In place with earthquakes, buildings must be flexible. This means they can bend without breaking. This is called ductility. Engineers want buildings to have high ductility to resist falling. Many building codes already require this for earthquakes, but explosions are different from earthquakes, so buildings need special design to handle both. Another important idea is redundancy. This means using extra support in case one part fails. If one column is broken by a bomb, the building still stands. There are not many rules about redundancy, but some groups, like the National Institute of Building Science, give helpful design tips. In the World Trade Center towers, the steel became weak from fire, but concrete stays strong. Even when it's hot, concrete does not burn or melt. The new World Trade Center used very thick concrete walls and strong steel bars inside. These walls help keep a building standing even after a big explosion. Explosions put a lot of pressure on concrete. Normal concrete can hold about 3,000 to 6,000 pounds per square inch, but new concrete used in the World Trade Center can hold 12,000 psi. Some new types of concrete can hold up to 30 psi. This is possible because scientists make the particles in the concrete very small and tightly packed. To make concrete even better, engineers mix in tiny steel fibers. These are like very small needles that stop cracks from spreading. This new material is called ultra-high performance fiber reinforced concrete. It is very strong and flexible. Tests show it's very good at resisting damage from explosion. In the future, more buildings will use this material to stay safe during attacks. Engineers today are using better design and stronger materials. Their goal is to make sure buildings stay standing even if there is an earthquake or an attack. These improvements will help save lives and protect people from future tragedies. Let's move on to the question. Task 1. Let's answer by two of us. 1. Engineers were always very concerned about progressive collapse before 1995. It's false. 2. The World Trade Center towers collapsed because the earth breaks the steel. It's true. Concrete becomes weak and melt in a fire just like steel. It's false. Ductility means a building can bend without breaking. It's true. Redundancy in construction means using more columns or support in case one fails. It's true. 6. Ultra-high performance fiber reinforced concrete is strong, flexible, and good at resisting explosion damage. Is true. Task 2. We have to choose the correct answer. 1. What material stays strong even in high heat? It's the concrete. 2. What does redundancy in building design mean? It's C. Introducing extra support in case one fails. 3. What is the strength in PSI of normal concrete? The answer is B. 3,000 to 6,000. 4. What improvement make ultra-high performance concrete resist damage better? Answer is C. The tiny steel fiber mixed into it. And the last one, 5. What is the main goal of modern engineers in designing buildings after these tragedies? D. To make buildings stronger and safe in disaster. So we have finished. Thank you again for listening.